We're back. This unit is all about inheritance, and we're going to start out these lecture slides by talking about the benefits of inheritance, which will lead us directly into talking about polymorphism. And we should hit this recap. With inheritance and the extends reserved order, we can now model ISA relationships between classes in our programs. I would say this is a benefit of inheritance, right? The whole thing fits into object-oriented programming. Object-oriented programming seeks to model the real world and make programs a little bit easier to follow as a result, make them more intuitive, kind of easier to design. That may be a bit of a stretch. But object-oriented programming would fall apart if we couldn't represent ISA relationship, right? Student is a person. Teacher is a person. But that's not the only benefit of inheritance. Inheritance reduces duplicate code, as instance variables or methods can be defined in a superclass and inherited by the subclass in the class hierarchy. We've seen this, right? Inheritance reduces duplicate code. Perhaps most importantly, inheritance enables polymorphism. Before we discuss what polymorphism fully is, let's recall that objects and the variables that reference them are two separate entities. Here I have the construction statement. We're creating a person called P1 and saying it is a new person. That is functionally equivalent to creating a person variable and then assigning it a person object. Okay. The variable declaration is separate from the object construction. We frequently do them together, but they can be separated. With objects, we actually separate them more often because you'll see instance variables defined in the body of the class and then later initialized. Okay. I remember showing this to you basically very early on when we first got introduced to variables. This concept was there, but then we quickly kind of move into this thing where we declare and initialize at the same time. Don't forget, it's two separate things going on. Variable declaration, object construction. Okay. With inheritance, superclass variables can reference subclass objects. The variable here is person. I'm able to do this because person is extended by student. Person is a superclass of student, is the superclass of student, in fact. Okay. This essentially is polymorphism. Polymorphism is the ability for an object to take on many forms. I don't like this definition, right? It doesn't really tell me what polymorphism is and when it comes to coding. Realities are I can't tell you what polymorphism is. I can show you. I can show you lots and lots and lots of examples, and that is the best way to kind of figure out what's going on. But definition alone is not going to get you there. Note that a subclass variable cannot reference an instance of a superclass. This does not go the other way. Here, I'm trying to save in a person object into a student variable. This does not work, assuming that student extends person, because student is the subclass here. You can kind of think of it as something bigger trying to go into something smaller, or something more generic trying to go into something more specific. So, the data type of the variable, the compile time data type, dictates which methods can be called. Right? There's implications with this, other than it just being cute. There's implications. The data type of the variable, I'm talking about this thing over here, right? The data type of P1 is person. The data type of the variable is person. The compile time data type is person. That is going to dictate which methods can be called. In this example, P1 will be able to call person methods, but not student methods. Let's demonstrate that before we actually take a look at the next thing. I'm in my person project. I'm going to flip over to the driver, and we'll go ahead and get rid of this stuff. First thing I want to show you, person is equal to a new student. IntelliJ's happy. This is not a syntax error, okay? What the slides are telling us, the data type of the variable, the data type of P1, the compile time data type of P1 is person. This tells you what methods can be called, all right? If I do person dot, take a look. We got get first, get last, set last. There's a toString. These are all person methods, right? Ignore some of these down here. But these things are coming out of the person class. P1 will be able to call person methods, but not student methods. What's missing here is things like get ID, get GPA. Okay, those are unavailable to me. The data type of the object, that's over here on the right-hand side. This is the runtime data type. It dictates which version of the methods will be called. Wait, what do you mean versions? Keep in mind that with inheritance, we now have the ability to override methods. What do I mean? Person has a toString method, but so does student. With polymorphism, I have a compile time data type. I also have a runtime data type, effectively the data type of the variable or the data type of the object. The compile time data type tells me what I can call. Right, here's methods that I can call. Of note, there's a toString method here. Okay, why don't we quickly print off our person? Keep in mind that whenever we do this, we are implicitly calling person.toString. I can do this because person has a toString. But what actually happens is this is the student's toString, right? The compile time data type here is person. I can only call person methods. I'll demonstrate that one more time. Right? I don't see anything about ID. I don't see anything about GPA. However, whenever I actually did call the toString method, we can call toString because person has a toString. But when I did call toString, the version I got was students. The data type of the object dictates which version will be called. In this example, if P1 calls toString, student's toString will be called, not person's toString. So we just demonstrated that. Okay, so this works for all types of things, right? So like I can do P1 is a new teacher. Why does this work? Ignore this for a moment. Why does this work? That's because teacher extends person in our class hierarchy. It's just mad at me because it wants this other stuff, which I don't want to give it right now. I can do person P1. We'll come back to that one. I can do student S1 is equal to a new college student. Again, it's going to be mad at me because there isn't a no-args constructor for college student. Why can't I do this? Because college student extends student. The thing I wanted to kind of gloss over, I'll go ahead and hit it because I know you're curious. What if I said person is a new college student? Can you do this? Yes. We'll come back to this. So, that's neat. This is the thing you can do. But what do we really gain? Why is this useful? All right, to demonstrate the benefits of this, let's consider having the teacher class. Apparently, I plan to write teacher here. We already have teacher, right? We have a class hierarchy kind of like this. We, of course, have college student underneath this, but we have student and teacher are both extending person, okay? So consider that exists because it does. Now, let's consider a checkout method, maybe defined in a class called library. So I have my library class, I have checkout, and we're saying that in order to check out a book from our library, we need some information. We need to know who is checking it out, In what book? Here, we're defining some parameters. A person in a book. Obviously, this checkout method will accept a person object as an argument. Additionally, thanks to inheritance and polymorphism, checkout will also accept a student or teacher object. So not only does this take in a person, it can take in a student and a teacher because those things essentially are subclasses. Okay, think about, let's maybe demonstrate this idea. I'm going to right-click on my SRC, make a new Java class. I don't really plan on fleshing this class out, but I'm going to throw in that, we'll do it like a no-args constructor. I technically don't have to do that either because one will be created for me. There's really no instance variables currently, but I'm going to plug in this checkout method. And it's going to take in a person. It's going to take in a book, which doesn't exist. Let's just take in a person for now. Okay. To demonstrate what I mean, I'm going to flip over to my driver. I'm going to create a library. I don't ever do this, by the way. This is brand new. If I take my library and tell it to check out, it needs a person. Well, I could, of course, just pass in a person. Notice that this is happy. But with inheritance and polymorphism, I could also pass in a student. Okay, this is very obviously a student. I'm going to use that checkout method. I'm going to feed it student, which is very obviously the compile time data type is student, the runtime data type is student, the variable name is student. This thing is a student. And my library method checkout will accept it, even though this doesn't say anything about student. This is polymorphism. This works because student is a person. This is one benefit, okay? How is this a benefit? Well, think about what we would have to do in the past. What you would have to do if we did not have this relationship established where student extends person, what you would have to do is overload this thing. You would have to write a checkout method that takes in a student. You would have to write a checkout method that takes in a teacher. Not a text component. Teacher. Right? You would have to overload the crap out of this for each of your object types. But with inheritance and polymorphism, you can just write the person one. Okay? It's likely that the checkout methods, right? It's likely that if you had these three checkout methods, that they would share a lot of similarities. They would have a lot of duplicate code. Yet, you would need to write them in order to handle all these different data types. Thanks to polymorphism, you would only have to write one. You could then include logic to kind of pivot based on the different types of things. So let's consider that checkout method. We have our library, we have our person. It can take in a person. It could take in a student, thanks to inheritance and polymorphism. It could take in a teacher. It could take in a college student. The functionality of the checkout method can then vary depending on the type of object passed in as an argument. So we're going to see in the future, inside the method, you can actually check to see what is the runtime data type of the thing coming in. This says it can take a person. In my example over here, I am actually passing it a student. In the future, we're going to actually be able to provide logic to basically say, if person is actually a student, do something like this. If person is actually a teacher, do something like this, right? The compile time data type of this variable is known to us. We know it's person. The runtime data type can change. It can be a student, it can be a teacher, it can be anything beneath the class hierarchy of person. Okay, that I have found has been pretty obscure to most students. You don't really understand it until you get into the thick of it. This, what I'm about to show you, becomes, this one's easier to grasp. I think most students are going to look at this and go, oh yeah, I get it. I get why polymorphism is good. Polymorphism has some rather interesting implications when it comes to data structures, arrays, array list. Consider a person array. Obviously, this person array will be able to store person objects. Additionally, thanks to inheritance and polymorphism, this person array will also be able to store student and teacher objects as they are subclasses of person. We're actually going to do this. I'm going to create an array or an array list that can store person objects, and we can pass in a person. Here I'm assigning it a student. This doesn't say anything about student. Here I'm assigning it a teacher. When this doesn't say anything about teacher, this is a benefit of inheritance and polymorphism. Let's do that. I'm going to delete this nonsense here. I'll leave it in place. I'm in my driver. I'm going to create a person array. Oh, people. Look at IntelliJ's learning. I'm going to create a person array called people. It is a new person array, and we're going to give it like a length of 3. Obviously, I can take people and save in a new person object. What is new and different is that I can take people and also save in a new student. I can take people and save in a new teacher. I'm going to make a no args real fast, so this is happy, and I don't have to pass in this stuff. We got to call it super. I'm going to give it... I've already got Bob Jones. That's like my go-to generic name. Bobby Johnson is our teacher, and I need to also initialize courses. We'll just make that a new array list of string and leave it at that. No courses there currently, but we will go ahead and initialize our names. So I'm back in my driver. IntelliJ's happy. People is a person array, and yet I'm storing in it a person, a student, a teacher. It's able to store these things because student extends person. Because teacher extends a person, right? These things are subclasses of person. So this works. Why is this cool? Well, what happens if I loop through this thing and print off each element? What? I'm going to say for integer I, let's use our shortcut syntax here. I'm going to loop through people. With each iteration, I'm going to print off people at I. Okay, why is this interesting? Let's take a look. The first element is a person, and we see Bob Jones. My second element here is a student, and we see Bob Jones along with the ID and GPA. My last is a teacher, and we see the Bobby Johnson name that I just plugged in, along with some empty courses. This is awesome. This is polymorphism. The data type of the variable dictates what I can call. What do I mean? The compile time data type of people at I is a person. Every one of these things has a compile time data type of person, effectively the data type of the variable. The runtime data type of each of these changes. The runtime data type of this element is person. The runtime data type here is student. The runtime data type is teacher. Why is this important? The compile time data type tells me what I can call, right? This element is able to call person methods, just the stuff defined in person. Okay. That restriction may seem weird to you to begin with, but the thing is, I know this is a person. Every one of these things, person, student, teacher, will at least have person methods available to them because at the very least, they will inherit them. However, whenever we actually call the method, the runtime data type dictates which version will be called. Each of these things is a person. I can only call person methods, right? I can only call get first, get last, toString, set first, set last. All of these things are person objects. They have a compile time data type of person. So we know that we are guaranteed to have those methods. ToString is an example of that, and that is what I'm calling here. We are implicitly calling the people at i.toString. When I'm on person, whenever I'm on the first element here, and the runtime data type is person, I'm calling persons toString. That's how we get this. When I'm on this element, the runtime data type is student. And that's how I get this. We're calling students toString. When I'm here, the runtime data type is teacher, so we're calling teachers toString. This is polymorphism. And this is super cool. Because think about this. This is my go-to example. wrong thing. In your video game, there are multiple things existing in the game world. But in order for those things to basically interact with each other, they have to be in the same data structure. What do I mean? Your video game that has a player and an enemy and items that has coins that you can pick up, those are all objects that have to exist in effectively the same 2D or 3D array. They have to exist in the same world. So in games, we have at the top of a hierarchy a shared class, game object. And underneath that are all these things. By giving them a common ancestor, they can all fit into the same 2D array, 3D array, etc. Okay, let me see if I can visually demonstrate this. Text. So let's say that I have a game object. What are some things that a game object might have, that all game objects might have? It might have what am I thinking? An X and a Y coordinate, right? We got X is an integer, Y is an integer. It's basically the location of the game object. Okay, let's say that they all share those things. Now, maybe I have my hero. This is the main character that I am playing. How do I move? Oh, how do I do things? These short keys are not Paint's short keys. Fine, he'll just live there. I have hero, and I have an enemy, and I have an item. Okay, these are all things that are going to exist in my game, but I need them to be able to interact with each other and collide with each other. So what we do is give them a common ancestor, something like a game object. What does this allow me to do? I can now create a game object, we'll say 2D array. If I got an XY, a 2D array makes a lot of sense. There we go. I can create a game object 2D array called world. And that is a new game object 2D array with, whatever size. Because these things are subclasses of game object, all of them can go into this. In the same way that all of my persons and students and teachers can go into my person array. Note that I was saying common ancestor. Right here, we're not going very deep. You could, right? In practice, you would probably have different types of enemies. Maybe you have a boss. Maybe you have a little lackey minion thing. And that those are types of enemies. Maybe over here under items, right? You got equipment, and you got coins. Those are basically subtypes of items. I said common ancestor because it's not just one layer deep. I'm going to make this array larger in just a moment. But we could also throw in a college student. Okay. Why is this interesting? Because college student extends student, not person, which extends person, right? That was 3 layers deep in our class hierarchy. I'm going to give it a no-arg constructor real fast. Oh my gosh, there's a lot of stuff. Our college student named AB with an ID of 0 and a GPA of 0. And a major of, yes, a minor of course. All right, I was just doing that to make this thing happy. I'm going to increase my array length to 4. I've got 4 things in here. IntelliJ is not mad, and when we run it, we're calling the college student toString due to polymorphism. But this thing is 3 layers deep. Person is ultimately a common ancestor. It is in college student is equal to or beneath person in the class hierarchy. That allows me to do this. I can save a college student into person. I am effectively doing this. That's basically what's going on here, right? You can think of this element in the array as just a variable. It's data type, it's person, it's compile time data type. Okay, same thing going on here. Ultimately, the common ancestor of minion is game object. Boss, game object. All these things are ultimately game objects. They're all going to have an XY location in my world. They can all go into this 2D array. So, polymorphism is awesome. It gets used all of the time. All right. What are some benefits of inheritance? We have ISO relationships. We can reduce duplicate code, and we enable polymorphism. True or false? Given that lamp extends light, light variables can reference lamp objects. Okay, what am I asking here? We'll go to Notepad for this. I'm saying lamp extends light. So we actually have a hierarchy kind of like this. I'm showing it sideways. That's a little bit unfortunate. What if I did this? Does that make everyone happy? Lamp extends light. Can light variables reference lamp objects? Can you do this? The light variable is referencing a lamp object. Yes. What about couch extends seat? I got couch at the top. I got seat underneath. Nope. I got seat at the top. I got couch underneath. Can couch variables reference seat objects? Can you do this? No. The data type of the blank dictates what methods a variable can call. That is the data type of the variable, otherwise known as the compile time data type. Right? In our examples here, we were talking about person. If I guess I could just comment this in. If I take this, I can only call person methods, right? If this were a student, first of all, I can do this because college student extends student. But the question is, what methods can I call? Notice that we have our get first and get last. Those were inherited from person. But we also have get GPA, get ID. Those were actually written in student itself. That's what I'm limited to. What's missing here? Get major, get minor. The compile time data type of this variable is student. You can think about it as the variable's data type. The runtime data type is college student. You can think about it as the data type of the object itself, right? Variable, object. So the compile time data type dictates what we can call. The data type of the object dictates what method will be called. So if I take that exact same student and call toString, we're going to call college students toString. I'll quickly prove that to you by printing off our student. I'm going to comment this out so we don't see that. So the only printout we should see is that of my student. And note that even though the compile time data type is student, what I got was college students toString because it includes a major and a minor. Just one quick thing. Compile time data type, runtime data type. I think these names get lost on students a little bit. Why have those names? The compile time data type of this parameter is person. I can see it right now. I know this is a person. The thing is, I don't know the runtime data type. Remember earlier, whenever we were calling this checkout method, and I was able to pass in a student, I was able to pass in a teacher. Just looking at my code here at compile time, I don't know what's coming into the method. I know it's at least a person because I can pass in person objects, but it could be a teacher, it could be a student. So I can, at compile time, tell what the data type of the variable is. I am unsure what the runtime data type is, what actual object is coming into this checkout method. Okay. We'll learn in a later video how to actually check for that. You can figure it out at runtime. Okay, is this actually a teacher? Is it actually a student? Something other than just a person. But we'll save that for a different video. I'll see you then.